Hello. Hello. Am I audible? Okay, okay. Good. We'll wait for some 5 minutes to let everyone join and then we'll start the session. Hello everyone. I hope I'm audible and visible to everyone. Can you guys confirm? Okay, cool. I think only this many people will join, so we'll start the session. So, first of all, happy Republic Day to all. We are starting the session on a Republic Day. I'll now share my screen and then we'll start. Is it visible to everyone?
Yes, ma'am.
Okay, cool. So, uh, welcome everyone to the first TA session of Biointerface Engineering. I'm Bhagyashree and I'm going to be your TA for this course for this semester. So, before we start, how many people here have a biology background? Uh, just a second. Yes, ma'am. So, two people have biology background. Okay, great. Uh, Hello, everyone. Welcome to the first TA session for biointerface engineering. So, what is interface in bio? A biointerface is the area of making contact with a biomolecule, biological tissue, cell, living organism, or organic or inorganic materials. And this course will deal with different forces, interactions happening in the interface, biointerface. So, this is the overall course layout. Week 1 will cover about intermolecular forces. Week 2, adhesion and wetting phenomena. Week 3, characterization of interfaces. Week 4, protein surface interactions. Week 5, protein aggregation. Week 6, protein surface cell surface interactions. Week 7, surface modification and characterization. And week 8 will cover about again week 8 will also cover about surface modification and characterization. So before we start the course, there was a prerequisite assignment um, named as week 0. So we'll first try to solve the week 0 assignments. So here is the first question from that assignment. What is the scope of biointerface? And the options are A. Nanotechnology, B. Biosensors, C. Biomedical engineering, D. All of this. So the correct answer for this would be all of this. So biointerface, as we were discussing in the first slide itself, is the interactions that's happening at the between the object and cells, tissue, or organism. So, in nanotechnology, for example, drug delivery or nanosense drug delivery, whatever things we are delivering through a vehicle, they are going to interact with the tissue or cells inside the body. And at the interface, there will be a different interaction. That is what this subject will cover. And then we have biosensors. So, imaging technologies such as atomic force microscope can say, so it detects the surface interactions and between the sensor of the atomic force microscope and the object, there is some interaction happening there. So you can say the biointerface also comes in biosensors. And then biomedical engineering, if we are to implant biomaterial in a body, uh, or inside a body, then it will have a specific interaction with the cells, tissues coming in contact with these implants. So in this sense, nanotechnology biointerface has a scope in nanotechnology, biosensors, biomedical engineering, basically all of this. Now, here is the next question. What is the nature of the Teflon coated non-stick utensils? So here the correct answer would be hydrophobic. So Teflon coated non-stick utensils, these are common utensils that we mostly have in our homes, and we use this for cooking. And if you try this, if you try pouring water on it, you can see droplets of water instead of covering the entire surface. You can see droplets. That is because the surface is hydrophobic, that is water hating. So the droplets are formed of water instead of it covering the entire surface. Now, the next question was, which of the following techniques cannot be used to detect the biointerfacial interaction? So here the correct answer is sputtering. So sputtering is basically coating. So high energy electrons are bombarded that displaces the material and coats on the other surface. So using high energy electrons, you can coat a surface with uh, another, such as gold, another material. This is called sputtering. Whereas atomic force microscopy, quartz crystal microbalance, surface plasmon resonance, these are well established microscopic and micro, well established techniques that can be used for studying the biointerfacial interactions. For example, in atomic force microscopy, it uses a cantilever with a very sharp tip to scan over a sample surface. And as the tip approaches the surface, there are attractive and repulsive forces between this tip and the surface. And based on this interaction, the instrument is able to detect the surface, about information about the surface. Next, we have quartz crystal microbalance. So this quartz crystal microbalance, it in this there is a piezoelectric biosensor, and this biosensor detects resonance frequency to variation associated with change in mass. So initially, if there is a mass, based on addition or removal of mass from there, there will be change in frequency of oscillation, and that will be detected by this quartz crystal microbalance. And the third one was surface plasmon resonance. So this is again another optical method for detecting biointerfacial interactions. So herein, uh, in a prism, there is the so basically it has, it's something like a prism, and at the bottom metal surface there would be objects, antibodies, cells, or whatever, and then there is an and incident light and a refracted light. This angle of incidence changes based on the interactions happening at this place. So that is how it detects changes of binding or dissociation of, or different interactions happening between objects. So all these techniques basically can be used to detect biointerfacial interaction except for sputtering. Now this was the next question. Which of the following technique cannot be used for interpreting the unfolding behavior of protein? So here the options are Fourier transform infrared spectroscopy, B circular dichroism, C fluorimeter, D atomic absorption spectroscopy. So the correct answer would be atomic absorption spectroscopy. All the other options, such as Fourier transform infrared spectroscopy. So FTIR detects the absorption by different bonds in the protein, and so if there is a change in this bonding between these bondings, then FTIR will able to detect that. Similarly, circular dichroism using polarized light, it detects the changes in the structure of a protein that changes during folding and unfolding behavior of the protein. That can be also detected by circular dichroism. And the last one is fluorimeter. So using fluorimeter also we can detect if we have a dye or something that uh, interacts with the folded protein or the unfolded protein, we can use that using fluorimeter to detect that. But atomic absorption microscopy, what it does is, basically in this technique, it determines how much of certain elements are present in a sample, and it basically acts on the of uh, absorbance of light by different atoms, ions, and molecules. So whether the protein is folded or unfolded, the elements are not going to change. So atomic absorption spectroscopy won't be able to tell us about the this technique, about this unfolding behavior of the protein. Okay, so we have the next question now. So the question is, which of the following firstly interacts with biomaterial when administered in body? Options are A. Proteins, B. Immune cells, C. Nucleic acid, D. Carbohydrates. So the correct answer would be A. Proteins. So the question is, which of the following first interacts with biomaterial when administered in body? And if you see, so if this is our biomaterial, first of all it will come in contact with water, and then there will be circulating proteins that are circulating in the body, in the blood vessels. So this will next come in contact with these proteins, and then these proteins attract these cells. So, and inside the cell, in the other options were immune cells, nucleic acid, and carbohydrates. So nucleic acid is basically inside the cells, and these are the cells. But then carbohydrates also will come later. So proteins after water, protein comes next in contact with biomaterial when they are administered in the body. So the correct answer would be proteins. Now here is the next question. How does detergent work? And the options are A. Lowering of surface tension, B. Increasing of surface tension, C. Lowering of electrostatic forces. D. Increasing the viscosity. So the correct answer here would be lowering of surface tension. So if you see, if this is the water surface, this has strong, the surface tension of water is really strong. And how detergents work are, detergents have a hydrophobic tail and a hydrophilic head. So these head interacts with the water surface because they are hydrophilic, and as they interact with them, they break the surface tension or basically lower the surface tension of water, and that is how they are able to interact with the stains, and they form the micelles around these stains, hydrophobic stains, and help in removal of them with the help of interactions with water as well. Now here is the next question. uh, which is the weakest force of nature? So there are four fundamental forces of nature: electromagnetic force, gravitational force, and then strong nuclear force, and weak nuclear force. So out of these electrostatic and strong and weak nuclear forces, these occur at atomic level or molecular level, but this doesn't happen at the small level. There is a large range. So these are the weakest. The gravitational force will be the weakest force of nature. Now, this is the next question. Which of the following is not bioimplant? The options are A. Sutures, B. Pacemakers, C. Spectacles, D. Stents. So, first of all, what is a bioimplant? So, a bioimplant is basically a medical device that is used to replace a missing biological structure or to support a damaged biological structure or enhance the existing biological structure. So, it will basically replace or support, replace a missing part or support or enhance a biological structures. So if you see suture, so we can see we can when there is a wound or something, using these sutures we seal the wound, whether internal or external. And then we have pacemaker. So the pacemaker is basically to maintain the heartbeat. This is implanted in the heart. And then we have stents. So stents are basically implants. uh, Stents are basically used to open the blockages in the blood vessels. So stents are kind of like these uh, small balloons. They are inserted into these blood vessels and then they are inflated. That will open up the basically open up the blockage if there is a due to excessive cholesterol deposition or any other obstruction. If there is blockage in the or narrow the blood vessel has narrowed down, these stents are used to increase the blood vessel diameter so that blood can flow easily. So all of these are basically used inside our body to for a missing biological function, or to enhance or to support existing biological structures. Whereas spectacles, we use this outside of the body. While it helps in uh, enhancing our vision, it doesn't it isn't necessarily replacing a biological structure or something. So the spectacles here would be the correct answer because it is not implanted in the body. Okay, so this was all about the week 0 prerequisite assignment that we had. And then after this, lectures are covered. So in week 1 lecture, uh, these topics were covered. The four fundamental forces of nature, as discussed earlier, such as the electromagnetic, gravitational, strong nuclear force, weak nuclear force, etc. Then we have the intermolecular forces timeline, where they discuss uh, the intermolecular forces starting from the 17th century to the 20th century, and then the Leonard Jones potential. Basically, they talk about different working potentials and the analysis, as well as the analysis of the attractive and repulsive forces, the nature of the Leonard Jones potential. So this was all covered in week 1, and then week uh, week week 1 lecture 1. Then there was week 2 lecture 2 as well, where classification of intermolecular forces was discussed. And in lecture 3, thermodynamic aspects of the intermolecular forces was discussed. So after covering the week, like these three lectures, lecture 1, 2, and 3 of week 1, there will be week 1 assignment. And we'll now look into this, solving this week 1 assignment. So here is the first question. So the first question is, what are the key features of van der Waals forces? Options are A, long range, B, non-additive, C, attractive, D, all of this. So according to the lectures, the correct answer would be all of this, because van der Waals forces are long range, they are non-additive, and they are attractive as well. The correct answer would be option D, all of this. Now, this was the next question. What is the origin of van der Waals forces? Quantum mechanical in nature, option A. Option B, physical. Option C, electrochemical. Option D, none of this. So here the correct answer would be option A, quantum mechanical in nature. Next question was, who proposed the interaction pair potential? Option A, Wayne. Option B, van der Waals. Option C, Arnold's. Option D, Rutherford. So here the correct answer would be Wayne May. So Wayne May proposed the interaction pair potential. And now we have the next question. The values of constants n and m in the Leonard-Jones potential equation are option A 3 and 4, option B 1 and 5, option C 6 and 12, option D 5 and 10. So the Leonard-Jones potential is given by the equation potential equals minus A by R to the power n plus B by R to the power m. Okay. And the Wien May potential can relate with the constants A and B of van der Waals equation, and then we get this to the power 6 plus B R to the power 12. So the correct answer would be 6 and 12. Here is the next question. What type of interaction forces stabilize the protein structure? So here the correct answer would be all of this. Option A, covalent forces. Option B, hydrophobic interaction. Option C, hydrogen bonding. All of these forces stabilize the protein structure. So the protein structure is basically formed by individual amino acids, which has a R group, a carboxylic group, and a amine group. And a amine group. So these, first of all, the bonding with the carbon results in the covalent forces, and the covalent forces stabilize the entire protein structure. So in a protein, these are then further connected to N, then to another amino acid. And so on. And this. So here, this is basically our first amino acid, and this is the second amino acid. And in a protein, the amino acids will continue to bond like this. And these covalent forces, that is bonding between with all the carbon in the chain, results in the covalent forces that forms the main structure of the protein. So that is really important for stabilizing the protein structure. And then we have hydrophobic interactions. So these amino acids, based on their R group, some amino acids are acidic, some are basic, some are hydrophobic, some are hydrophilic. So these hydrophobic groups, when uh, when they are exposed to hydrophilic solution, the protein hydrophobic core come together to interact with other hydrophobic residues, and that is how they stabilize the entire protein structure in a hydrophilic solution. So hydrophobic interactions also help in protein structure stabilization. And then we have hydrogen bonding. So the proteins have alpha helix and beta sheet, these kind of structures which are stabilized by hydrogen bonding between different uh, amino acids at different positions. So basically all of these forces, such as covalent forces, hydrophobic interaction, and hydrogen bonding, all of them participate together in stabilizing the protein structure. Answer would be D, all of this. Okay, here is the next question. Which of the following are responsible for generation of electric charge on the surface? Dissociation of surface groups, association of surface groups, binding of excess ions. Again, here the answer would be all of this. So generation of electric charge. So charges could be both positive or negative. Suppose there is a uh, neutral surface here, and if there is dissociation of the sum of these charges, then it will lose some of the charges, making it negative. But if there is addition of some surface groups, that can be positive. Well, it also depends on the surface groups, whether positive groups are added or negative groups are added. Depending on that also, the charges can change. And then binding of excess ions, whether positively charged ions or negatively charged ions are added on the surface. Based on that, it will change the charge of the entire surface. and all of these would be responsible for generation of electric charge on the surface. So the option would be D, all of this. Now, here is the next question. What is the unit of dipole moment? So the options are A, debye, B, coulomb, C, hertz, D, meter. What is the unit of dipole moment? Here, the correct answer would be option A, debye. So dipole moment is basically a product of the magnitude of charge into the distance distance between the centers of positive distance between the centers of the positive or negative charges, basically distance between the charges. So the charge is given by coulomb C, and distance is given by meter. So this is coulomb meter, but we have a separate unit to for this coulomb meter, which is called debye, and this is the unit of dipole moment. Now here is the next question. The value of gravitational constant G is option A, 66.7 into 10 to the power minus 11 Newton meter square per kg square. B, 6.67 into 10 to the power minus 11 Newton meter square per kg square. C, 66.7 into 10 to the power minus 10 Newton meter square per kg square. D, 6.67 into 10 to the power minus 12 Newton meter square per kg square. So here the correct answer would be option B, 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the constant value and it will always remain this same. Okay, so now we have a numerical question. So here is the first question. What is estimated gravitational force between the Earth and Moon? Mass of Earth equals to 5.97 into 10 to the power 24 kg, and mass of Moon equals to 7.35 into 10 to the power 22 kg. The distance between Earth and Moon is equals to 382,500 kilometers, and the estimated force is option A, 2 into 10 to the power 20 Newton, B, 7.66 into 10 to the power 28 Newton, C, 2 into 10 to the power 26 Newton, D, 4 into 10 to the power 20 Newton. So we'll now try to solve this question. So it is asking about the gravitational, sorry, is asking about the gravitational force, and gravitational force is given by F equals to G, which is our gravitational constant, into M1, M2, which are the two masses, by R square. Okay, so G is constant, which we discussed in right before this question, which is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And then we have M1, which is this 5.97 into 10 to the power 4, 10 to the power 24, by, this is M1, and then M2 is 7.35, 7.35 into 10 to the power 22. So this is all G M1 into M2, and then we have our R. R is in kilometers, so we'll try to convert this into meter. So basically this is 382,500 kilometers. 1 kilometer is 1000 meter. So we'll simply multiply 1000 with this. And then we'll put square over this. Okay, so now if you multiply 6.67 into 5.97 into 7.35, this will give you 292.67, and then 24 plus 22 minus 11 is 35. So this will be into 10 to the power 35. Similarly, the bottom product would be 1.46 into 10 to the power 11 plus 6 is 17. Okay, so basically the 292.67 divided by 1.46 will give us 200.45, 145. So let's keep it 5. Then we have 35 minus 17 would give you 10 to the power 18. which can be also written as 2.0 into 10 to the power 20. And now for the units, this was for G, it was Newton meter square per kg square. And then we are multiplying M1 and M2, basically 2 kgs or again kg square. And then this entire thing is divided by R. We've converted this to meter, so that is meter square. These units will get cancelled out. Meter square will also cancelled out, so the remaining is Newton, which is the unit of force as well. So our answer would be 2 into 10 power 20 Newton. Option A will be the correct answer. Okay, so here is the next question. What will be the density of air kg per meter cube at the outer layer of troposphere, that is 10 kilometer above sea level? And we have to assume T temperature equals to 25 degrees Celsius, density at sea level as 1.225 kg per meter cube. The options are A 3.73, B 0.4, C 1.55, and D 0.9. So for density, we'll follow the formula rho density 2 by the ratio of density, that is density 2 by density 1, is given by E to the power minus m is mass, g is acceleration of gravity, z is the distance, and then we have Boltzmann constant K and temperature T. So we'll try to solve this. We have to find rho 2. Rho 1 is given, or density 1, which is 1.225. So density so density 2 will be equals to density 1 into e to the power minus m g z by kt, which is equals to 1.225 into e to the power minus, so here m would be mass of air, which is 1.67 into 10 to the power minus 27 into 28, and then G, acceleration due to gravity, is 9.8. Then we have our Z, or the distance, that is 10 kilometers, which we'll write in meters, which is 10 into 1000, basically 10,000 meters. Then Boltzmann constant, 1.38 into 10 to the power minus 23 10 power minus 23 into 298 into 298 Kelvin. So the temperature is 25, so 273 plus 25 will give us 298 Kelvin. Now all of these units, whatever is on the top and bottom, this will all cancel out. And the final unit will be only of this kg per meter cube. Now if you try to multiply this and divide by this, it will give us 1.225. 1.225 into e to the power minus 1.11, which is again 1.225 into e to the power, sorry, e to the power minus 1.11 would give us a value of 0.329. So this will be into 0.329 1.225 into 0.329, which will give us a final value of 0.4037. So the correct answer would be option B, 0.4. Now, this was all the problems and assignments for the prerequisite assignments for week 0 as well as the uh, week 1 assignment. And in the next session, week 2 TA session, we'll solve the week 2 assignment. Thank you for joining.